Now, after we understand how to find KSP, we can also make use of the KSP and some given concentration to find out whether a precipitate will form. Now, if you look at here, this is an equation given, and we have two solutions mixing together. And then these two are our products. This is just a simple double replacement reaction, and we should have no difficulty getting these two products. Now, to move on, we have to first understand which one of these two could be a precipitate. So based on the solubility rules, we understand that all the group 1 compounds, when they are in water, they are soluble. So we would say this is soluble, so we put down aqueous next to the chemical formula. And that means this is the one that will be a solid. Or if you refer to the solubility rules, you should also find out that lead sulfate will be a solid, will be an insoluble solid. As we were going over these materials, we said that yes, they are insoluble, but in chemical sense, then they are actually slightly soluble, barely soluble. So we are going to apply the KSP for this particular solid. And here comes the question. We have such a small amount of solution with such small concentration. Are we really going to form precipitate? That's the question we have to find out. That's the question we have to answer ourselves. So, what I want to focus at the very beginning of this tutorial is that these given values are the values before they are mixing together. So let me just put some notation right here. These are before mixing. Okay? And since we would like to use the KSP, that means we will have to write an equilibrium reaction that involves this precipitate. PbSO4 solid, Pb2 plus SO4 2 minus. And now you may ask, why do we have to write this equation? Can we determine whether it will produce a precipitate or not based on this reaction, based on this equation? Well, we would like to see if the concentration of the ions has reached the maximum amount. We would like to see if the solution right here, if the ions, the concentration of the ions has exceeded or not, has exceeded the solubility, the maximum amount for the ions to exist in the solution. So in order to find out whether or not it will form a precipitate, it becomes an equilibrium problem. And what we would like to see is that would the equilibrium shift to the left? The reason why it has to shift to the left to form precipitate is because, well, if the ions has not reached an equilibrium level, there's no shift. And if there's no shift, the solid would not form. The only moment that the solid will form is when there is an equilibrium shift to the left. Okay, so this is something that we would like to find out. So the way we do this is by using the reaction quotient, the Q, because we can use the Q to compare the K and see which way will it shift. And you can understand this from the previous tutorial. When we try to find out what the Q is, it is basically the same thing as the K, except that the concentration that we're putting here for the calculations are not the one at the equilibrium. The concentrations that we're putting here are the ones that are the initial concentration. Now, let's go back to the concentrations right here. The reason I put down before mixing for these values is because when they mix together, the concentration changes. The concentration of each solution would change because the volume changes. When they mix together, 0.1 plus 0.4 liters is going to get you 0.5 liters. And this is why we have to be very careful about the concentrations. We have to be very careful about the numbers. What do they represent in the problem? So because these are the concentrations before mixing, we would have to find out what's the concentration after mixing. So because of the time issue, I have my numbers ready. And just to tell you how to calculate the concentration, you can always use the M1V1 is equal to M2V2 to calculate what is the new concentration. In this case, the V2, the new volume, is 0.5 liter. So after, okay, the concentration of each solution is going to be 1.6 times 10 to the negative third. And this is going to be 4.0 times 10 to the negative third.